हेलो स्टूडेंट्स, गुड इवनिंग टू ऑल ऑफ यू. सो हियर आई एम गोइंग टू डिस्कस सम इंपॉर्टेंट प्रॉब्लम. और ये प्रॉब्लम सीबीएसई सैम्पल पेपर फॉर द सेशन 2023-24 का केस बेस्ड क्वेश्चन है फ्रॉम द सेमीकंडक्टर. सो लेट्स स्टार्ट विद दिस प्रॉब्लम नंबर 1. यू कैन रीड दिस पैराग्राफ जो कि पेपर में दिया होगा. सो इट विल ऑल्सो हेल्प इन सॉल्विंग द प्रॉब्लम. So let's start with the first question. So we have a diode and connected with the external resistance 100 ohm, and EMF of this cell is basically 3.5 volts. Barrier potential is across the diode is 0.5 volt. So current in the circuit will be. So basically in this circuit we have a cell of voltage. It is 3.5 students. Cell of voltage. Voltage is equal to 3.5. But here the barrier voltage is 0.5. So barrier voltage जो है अपने पास 0.5 है. Barrier voltage. So basically जो net voltage है, net voltage in this case is like 3.5 minus 0.5, it means 3 volt. So 3 volt is the net voltage because there is a barrier of 0.5 voltage. So then we have to calculate the current. So we have a diode, so there is no resistance of connected to external resistance 100 ohm, no resistance of diode is there. So we simply calculate the current, that is simply voltage upon resistance. So effective voltage is 3 volts and resistance is 100 ohm. So it is 3 upon 100. So we can say that it is 3 into 10 raised to power minus 2, or we can write it as like 30 into 10 raised to power minus 3. We can write it as 30 into 10 raised to power minus 3. So this is a 30 milliampere is the answer. We have to write in terms of, this is basically in amperes, but we can say this is 30 milliampere. So option D is the correct answer. Now let's come to the second question there. In which of the following figures the diode is reverse biased? So reverse biased means whenever that P side is connected to lower voltage there, in comparison to N side, the circuit is said to be in reverse bias. So iska jo answer है, its answer is basically option C there. C is the answer for this question. Like here this P side is being connected to diode ka jo P side, it is being connected to the ground, so its potential is 0 volt, and the negative side is being connected to 5 volts. So if this type of case is there, this type of condition is there, like P side is connected to lower voltage in comparison to the N side, the diode is said to be in reverse biasing. So this is C option is the correct answer. Let's come to the third question. Based on the VI characteristics of a diode, we can classify diode as, so diode is basically a non-ohmic device, so it is not going to follow that V and I proportionality relationship there. So for example, it's like voltage graph is basically not like linear. For example, this type of graph is not there. It is for the ohmic materials. So for non-ohmic materials we have this type of variation, like non-linear variation. So this diode is basically a non-ohmic device. Option is the correct answer. Now let's come to the question number third, or option. This is in the choice of this third question. So we have two identical PN junction can be connected in series by three different methods as shown in the figure. If the potential difference in the junction is the same, then the correct connections will be. So here basically we have a different identical PN junction. So like this is PN, this is NP, PN, NP, इस तरह से ये कुछ connected है. So here the condition is that if the potential difference in the junctions is the same, so they are connected in series and potential difference in the junction is same for all these connections. So what are our possible answers? So students, like this is PN, like अगर आप option 1 में देखें, in this case like P is connected to positive and here in this case P is connected to negative. So this particular diode is in forward biasing and this is in reverse biasing. Negative is being connected to P side. So one of the set is like one of the diode is in your forward biasing and other is in your reverse biasing. So voltage across these two diodes is not same. So but according to the question, potential difference in junction is the same. So that is only if like both diodes having same type of biasing. Like here this P side is being connected to positive, and for the second case there, for the second choice or second combination there, second diode there, N side is being connected to negative. So this is also in forward biasing, this is also in forward biasing. So this type of condition, like in this case across the both the junctions the voltage is same. So this is correct choice, correct connection there. Or otherwise we have this type of connection, like here N is being connected to positive and here P is being connected to negative. So this is also in same biasing, this is also in same biasing, means we can say that they are in the reverse biasing and this is also in reverse biasing. So the choice for the, so such that the potential difference will be same, it is like connection is like PN, PN, or otherwise it should be NP, NP. So ये है हमारे पास option like case 2 and case 3. So this is option B, case 2 and case 3, or the circuit 2 and circuit 3 is the answer for this question. Now let's come to the last part of this case based question. VI characteristics of a diode is shown in the figure, and the ratio of the resistance at the diode at 15 milliampere to the resistance at voltage minus 10. So we have to calculate the resistance of this diode at when current is 15 ampere. So we know that resistance is basically voltage upon current. So this is a non-linear device, so we have to take the formula for resistance is like delta V upon delta I, and again in the we have to calculate the ratio. We have to calculate the resistance at V is equal to minus 10 volts. So this is also written as like delta V, or we can say that delta V upon delta I. So we have to take this ratio. So whenever we are going to calculate the resistance value at current is equal to 15 ampere, the voltage, like here we can see that this is basically 0.8 volt and this is 0 point, because we have no data for that 15 milliampere current. We have no corresponding data of voltage. We have to take this interval there. So delta V for this 15 ampere case, delta V is basically 0.8 to 0.7. So I'll write 0.8, sorry, I have to write here 0.8 minus 0.7, and it is being divided by, so divided by the corresponding current is 20 and other one is 10. 0.8 के corresponding 20 है, 0.7 के corresponding 10 है. So I will write 20 minus 10, or it is written as 10, but it is in milliamperes. I will write 10 raised to power minus 3 as well. So this is the case. Now ratio हमें एक और लेना है साथ में. Now we have to take the voltage or minus 10, हमें resistance निकालना है minus 10 voltage पर. So voltage is minus 10 and the corresponding current is, this is in reverse biasing, is 1 microampere. So again for this delta V I will write minus 10, or for the magnitude I simply write the 10 there, and delta I, or because there is no delta I, the current is basically constant there, it is in reverse biased, that is 1 microampere, that is 1 into 10 raised to power minus 6 ampere. So students, when you take the ratio or do all the mathematics there, calculation there, you will get 10 raised to power minus 6. So 10 power minus 6 is the answer for this question. So this is the question from the sample paper, CBSE sample paper, case based problem. Thank you.